Hello everyone. My project is the automated path tracking robot based on Pixie 2 camera. So for my research project, there are four parts of my project: motivation, introduction, and our objective statement, implementation, performance evaluation. So let's look at the first part, motivation. For the motivation, there are many applications. The most two relevant applications for my project is the robot navigation and the autonomous driving. For the robot navigation, you can have an algorithm to move the robot around the space that you have defined. And the autonomous driving is let the car drive by itself and which means the driverless. The technologies they used in these applications have many technologies. So you can have environment perception, sensor fusion, and movement planning. For the environment perception, you use different sensors to perceive the environment to get the data feedback from your environment and use these data to move the robot. The sensor fusions is to handle different sensors. Like you can get many data at the same time, but you have to make sure that you can process this data and make a better choice for the next movement of this robot. The movement planning is to define an algorithm, how to move the robot, how to plan the robot. The second part is the introduction and the objective statement. For our research project is to move the robot, follow this line, follow this road. The road have two yellow lines and with a background with a black background. So our robot just move this road. The first thing you need to is to do the entrance finding. You have to find this entrance of this road. The second is to line detection. Line detection means that you have to detect this line, both in two modes. The first mode is the color. The second mode is the vector. The third part is to do the path following. You have to let the robot follow this path, and the obstacle detection and avoidance. And the final thing is the adaptive speed control. The hardware design in this project is to the Arduino and the Pixie 2 camera, the distance sensor, and the DC models. The Arduino board is the central part to develop the control algorithm. The Pixie 2 camera is to capture the pictures from the environment, and the distance sensor is to measure the distance. The software design is to develop an algorithm to find the entrance and follow this path. The third part is the implementation. For the implementation, there are two algorithms. The first algorithm is to find the entrance, and the second algorithm is to follow this path. As for the entrance finding, we have to do the color detection and the line detection also. And we have to do some obstacles detection and avoidance. Because at the start, the robot is to randomly place in the environment, which you have to define previously. And in this defined area, you have to make the robot to find the entrance. So you have to do some obstacles detection and avoidance. The color and the line is to find this road. For the path following algorithm, which is to track the path, you also have to do the obstacles detection. because in the past you have some obstacles. And also, the most important thing is to follow this path, which in our algorithm is to limit the vector, how much this distance are away from the road, which means we have to be clear. We have to be clear. That's the distance away. That's the distance from the robot, away the road from the robot. This distance is to make sure this distance. So we have to do the vector limitation, because if our robot is close or away from the line, we have to see that two lines in our road, the yellow line. If the robot are close or away from this line, the camera may not see the line, so our robot will lose the road. This is the essential part. So we have to do the vector limitation, which is to maintain a proper distance away from the yellow line, to make sure that the camera can capture the pictures and can use this data to move the robot. So once we have this picture, we can do the speed control. So first thing, we see the entrance finding algorithm. In the left hand side, there are two kinds of modes. The first picture is the yellow, is the color detection, and the second picture is the vector detection. For the color detection, we switch to the color mode to detect color, and for the line detection, we switch to the vector mode to detect line. And also for the line detection, we have to detect two side vectors to ensure our robot is positioned in the middle of this road. For the path following algorithm, so for our path following algorithm, there are two parts. The first is the path following, the second is the obstacle avoidance. For the path following, we have to do the line detection, and we also have to do the angle calculation. The angle is between the robot direction and the road. And we also have to do the steering and movement planning. For the obstacle avoidance, we have to do the obstacle detection and distance estimation to estimate the distance away from the obstacles ahead. And also the adaptive cruise control by adjust the speed based on distance is also should be done in the obstacle avoidance part. The performance evaluation. As for this part, we have three performance. The first is the entrance finding evaluation. We have to do this test in 50 trials 6% of the times. The robot was able to find the entrance between 16 and 23 seconds. And for the moving speed performance, you can see this picture. At the maximum speed, which is 150, the robot was able to traverse the entire course in less than 18 seconds. And for the smoothness assessment, is in this picture, almost in 1800 random measurements. The angle was less than 8 degrees in more than 57% of the times. So this is the whole evaluation of our research project. And thank you.